this is maybe their belief about how effective some particular medicine is or something like that. And then the agents all have neighbors that they talk to. It might be everybody if you've got a really simple model, or it might be just their neighbors on the social network. And then on each round of the model, they do something like averaging to update. So they talk to all their neighbors. They say, oh, I'm a 0.5 person, and Marcelo is a 0.9 person. So next I'm going to go to the average of 0.5 and 0.9. And so there's lots of extensions of these sorts of models, but there's a lot of discussion of models in the belief dynamics literature that work something like this. So it's been known for a long time, and if you try to program this, we have undergraduate students attend, but if you try to do this, you'll probably get a model that converges. So Abelson puts it this way: ultimate agreement is the ubiquitous outcome of a very broad class of mathematical models. And later on he says, what on earth must one assume in order to generate a bimodal outcome? Any kind of model like this, you can see everyone's going to collapse, because if you're doing something like averaging, everybody's just going to get closer together in what they believe.
Does it matter how many neighbors you can talk to?
There are ways of doing thin agent-based models with averaging like this where you can get polarization, so Abelson was actually wrong. Hegelsman and Krauss have a model like this from 2002 and a better version in 2004 where they do this sort of averaging and get polarized societies. And the way they do it is, if you only talk to people with beliefs near yours, then you can get groups that form. I'm happy to talk more about that later. It is possible, but I'm going to give up on averaging models altogether. All right, so here's a new model of group deliberation that doesn't involve any kind of averaging. Okay, so here's going to be the starting part. To model group deliberation, we're going to start with this idea that rational belief, what a group should believe, what a person should believe, is what's supported by their evidence, or what's supported by their reasons. So an agent's going to have a bunch of reasons, and what they should believe is what's supported by their reasons. And then deliberation in this model is going to be the exchanging of reasons. So I believe that abortion should be permissible. Why do I think that? Well, here's my reason. Okay, now we're discussing. In these particular models, we're going to assume that everyone hears everyone, and there's not going to be any analog of like shouting or threats or anything like that. One more thing about the model. The last thing is that in this model, sometimes agents are going to be able to get reasons from the world. Because we don't always figure out what we believe from each other, right? We learn a lot from each other, but sometimes you go out in the world, you do an experiment, and you figure out something. Somebody didn't tell you. Okay, so you can also get reasons from the world. So 12 Angry Men, the juror 8 goes to the pawn shop, finds the knife that's supposedly rare. Okay, that's a reason to think that the knife wasn't as rare as we previously thought, but that's a reason from the world. All right, how are we going to model reasons? A reason on this model is going to be a very simple thing. It's just going to be a thing that it supports, thinking that the 18-year-old is guilty of murdering his father, or not. And then it's going to be a strength at which it supports that concept. So a reason is just that. There's nothing else to a reason in this model. It's just guilty or not guilty, and then a strength, so maybe 3. So here's a little picture. So reason A is just a supporting of guilty with strength 3.2. In further models I'm going to show you, we're going to make some simplifying assumptions. So we're going to assume there's just 2 contents we're discussing, guilty, not guilty. We're going to assume there's lots of reasons. So here you can think jury trial again. So there's lots of things that might bear on whether or not this 18-year-old actually did kill his father. But few of them are very strong reasons. It's quite rare to have an eyewitness who says, look, I saw this guy do that. So then if we were to plot out the reasons, they might look something like this. So we'll give the reasons a positive strength that they support guilty, a negative strength that they support not guilty. Then there's going to be lots of reasons of strength 0 or near 0. They don't tell you much about guilty or not guilty. There's going to be very few reasons that tell you where it is. And then what we're going to say is that a person's belief is just the weighted sum of whatever reasons they have. Okay, so that's going to be the model of reasons. Obviously, this is incredibly simple, and you might think there's a worry here. So one worry is that that stems from this idea that the reasons just have basically no structure. They just support the concept of strength. The worry is that we can't even do simple interactive things with groups. So oftentimes what happens when you have a group discussing is that you could have people say different things, and those things come together to support something that neither individual part did. So maybe I know P, and Marcelo knows if P then Q. Well, then if I say P and Marcelo says if P then Q, then we can collectively conclude Q. right? But neither P nor if P then Q by themselves supports Q, right? So you might think our model of reasons is just too simplistic, right? It can't capture group deliberation. And the response to that is going to be a few things. So one, we're trying to give a really simple model. It's supposed to be a thin agent-based model. Here's another move if you don't like that. You could think of the reasons as lines of argument. That doesn't really get around the objection, right? But okay, then in our model, people can only exchange lines of argument for conclusions. They can't actually have this back and forth thing. But the last response is I'm going to come back to this, so we have a better response. But for now, just go with it. All right, the last element of the model is going to be memory. So some agents, according to epistemologists, but not according to anybody else, have perfect memory and never forget anything. But real agents are never like that, right? We all forget things. We have limits to how much we can remember. So if we're going to model this, we need to have ways that agents forget. So how are agents going to forget things? So one way they could forget things is when their memory gets full, they could just drop something at random. So that's really bad computer design, but you could do it that way. Another thing you could do that's probably more rational is you could forget the weakest reasons, the reasons that have the lowest strength. Forget those first because they don't bear as much on the conclusion. Here's another thing you could do. You could forget reasons that go against what you believe. So at any moment in time, you're going to have a collection of reasons. They'll collectively support something, guilty or not guilty. And you can look at your collection of reasons and go, okay, they collectively support guilty. So if I have to forget something, I'm going to forget something that supports not guilty, because that's a misleading reason. Okay, so those are three ways that agents could forget. So we're going to simulate this, and I'm going to show you some results from simulation. I'm going to show you two different kinds of runs. So in the first kinds of runs, they're going to go like this. So there's going to be 50 agents, and at the beginning, they're all going to get 7 reasons, just random. Each agent will get 7 random reasons in the world, possibly different. These numbers don't actually matter at all. We've done tons of robustness testing, and for all interesting numbers work, but I'm going to show you some of these. Okay, so 50 agents, they all get 7 reasons. And then a random person just says a random one of their reasons. Everyone's going to hear that reason, take it on board, adjust their beliefs. And then if the agents are limited, then everyone who has more than 7 reasons is going to forget one. So if everyone starts out with 7 and then a random person says a random one, well, not everybody's going to have more than 7 now, because the person who's speaking is not going to have more than 7. And if people already had that reason, they're not going to have more than 7. But if somebody now has 8, they're going to forget the reason using whatever forgetting rule we're simulating there. Okay, so that's pure deliberation. It's really simple. All that happens is we have this setup, you get your reasons, and then we do this repeating thing where a random person says a random reason, everybody adjusts their beliefs, and then everybody forgets if they need to. And then repeat. And a random person says a random reason, everybody adjusts their beliefs, everybody forgets. The other kind of run is going to be deliberation with outside input. Deliberation with outside input is very much like deliberation, the pure deliberation cases, except that before anybody says a random thing, everybody's going to get a reason from the outside world, just some random new reason. And that's going to repeat. So what's going to happen here is everybody's going to get a new reason from the outside world. One random person is going to say one random thing. Everybody's going to hear the reason that they said and adjust their belief. Then they're going to forget if necessary, and then repeat. Everybody gets a new reason from the outside world. Someone says the random thing. Yada yada. All right, so that's how we're going to do these simulations. If we're going to do these simulations, we need some ways of measuring the output. It turns out to be very difficult to specify formal measures of polarization. So sociologists have thought about this a lot, and if you look at actual sociological work, there's lots of... folks aren't very clear about exactly what the right measures of polarization are. My lab group and I have published a couple papers trying to clarify different ways you could measure polarization. So we have a paper in the Journal of Mathematical Sociology where we lay out 9 different measures of polarization. Here I'm going to give you 3 of the measures. The first one's not one of them. But I'm going to give you 3 of them for the sake of demonstrating the point. So if we're going to measure a group, so say we have a belief histogram. Here's all the people, their beliefs are jumping around. One thing we might measure about this is how quickly they converge. So if the group converges, how quickly does it take them to converge? And there's 2 different kinds of convergence that we could get. So one, we could get how quickly does it take them to converge on a view? How quickly does it take for everyone to be a believer in guilty or a believer in not guilty? Another question we could ask is how long does it take for them to converge on a set of reasons? So not just everybody believes they're guilty, but everybody believes the person's guilty for the same reason. Why are we measuring convergence? Well, because if a group converges, there's no polarization, right? Converged groups aren't polarized. Here's some better measures of polarization. So another measure of polarization that we could use is group divergence. So group divergence measures the means of the group. So group B here is more polarized than society A. So in A, the means are this far apart, and B, they're this far apart, so they're more polarized. Right? That's a natural sense of polarization. Here's another sense of polarization: how much consensus there is within the subgroups. So society A is less polarized than society B, because in society A there's more variation in what it takes to be a red person versus, and more variation in what it takes to be a blue person. In society B, the red people and the blue people are much more in agreement, so that's more polarized. Something to notice here is that the means need not be different among these groups, so the first measure doesn't capture that. A last measure that we'll use is size disparity. So here, society A is more polarized than society B because the groups are approximately the same size in society A, whereas in society B, the minority group is just a small part of the society. All right, if you're doing an agent-based model, you have to have a movie. So here's the movie of the model running. It's got a fun GUI. So up there, we see there's our 50 people, and they're all talking, and whether or not they're on one side or the other, by their color, red or blue. Here's the bleed histogram, giving away that there's a way that this could polarize. There's the reasons, and we've got lots of measures of polarization. get reasons from the world. So 12 Angry Men, you know, he goes, the juror goes, the juror 8 goes to the pawn shop, finds the knife that's supposedly rare, so that's a reason to think that the knife wasn't rare, $300, Alright, how are we going to model reasons? A reason on this model is going to be a very simple thing. It's just going to be a thing that it supports, thinking that the 18-year-old is guilty of murdering his father, or not. And then it's going to be a strength at which it supports that. So a reason is just that. There's nothing else to a reason in this model. It's just guilty or not guilty, and then a strength. So maybe 3. So here's a little picture. The reason A is just a supporting of guilty with strength 3.2. And for the models I'm going to show you, we're going to make some simplifying assumptions. So we're going to assume there's just 2 contents we're discussing, guilty, not guilty. We're going to assume there's lots of reasons. So here's the jury trial again. So there's lots of things that might bear on whether or not this 18-year-old actually did kill his father, but few of them are very strong reasons. It's quite rare to have an eyewitness who says, look, I saw this guy do that. So then if we were to plot out the reasons, they might look something like this. So we'll give the reasons a positive strength that they support guilty, a negative strength that they support not guilty. Then there's going to be lots of reasons of strength 0 or near 0. They don't tell you much about guilty or not guilty. There's going to be very few reasons that tell you one way or the other. And then what we're going to say is that a person's belief is just the weighted sum of whatever reasons they have. Okay, so that's going to be the model of reasons. Obviously, this is incredibly simple, and you might think there's a worry here. So one worry is that that stems from this idea that the reasons just have basically no structure. They just support the content of string. The worry is that we can't even do simple interactive things with groups. So oftentimes what happens when you have a group discussing is that you could have two people say different things, and those things come together to support something that neither individual part did. So maybe I know P, and Marcelo knows if P then Q. Well, then if I say P and Marcelo says if P then Q, then we can collectively conclude Q, right? But neither P nor if P then Q by themselves supports Q, right? So you might think our model of reasons is just too simplistic, right? It can't capture group deliberation. And the response to that is going to be a few things. So one, we're going to give a really simple model. It's supposed to be a thin agent-based model. Here's another move if you don't like that. You could think of the reasons as lines of argument. That doesn't really get around the objection, right? But, okay, then in our model, people can only exchange lines of argument for conclusions. They can't actually have this back and forth thing. But the last response is I'm going to come back to this, so we have a better response. But for now, just go with it. All right, the last element of the model is going to be memory. So some agents, according to epistemologists, but not according to anybody else, have perfect memory and never forget anything. But real agents are never like that, right? We all forget things. We have limits to how much we can remember. So if we're going to model this, we need to have ways that agents forget. So how are agents going to forget things? So one way they could forget things is when their memory gets full, they could just drop something at random. So that's really bad computer design, but you could do it that way. Another thing you could do that's plausibly more rational is you could forget the weakest reasons. The reasons that have the lowest strength, forget those first because they don't bear as much on the conclusion. Here's another thing you could do. You could forget reasons that go against what you believe. So at any moment in time, you're going to have a collection of reasons. They'll collectively support something, guilty or not guilty. And you could look at your collection of reasons and go, okay, they collectively support guilty. So if I have to forget something, I'm going to forget something that supports not guilty, because that's a misleading reason. Okay, so those are 3 ways that agents could forget. So we're going to simulate this, and I'm going to show you some results from simulations. I'm going to show you 2 different kinds of runs. So in the first kinds of runs, they're going to go like this. So there's going to be 50 agents, and at the beginning, they're all going to get 7 reasons, just random 7. Each agent will get 7 random reasons from the world, possibly different ones. These numbers don't actually matter at all. We've done tons of robust.
すいません。
At the University of Pennsylvania, and he is a philosopher who seems to be almost doing like what scientists do, but with a mind of asking questions like a philosopher would, right? And the title of the talk is Rational Polarization and the Importance of Forgetting Groups. We live in very polarized times, right, where we have a lot of discord and a lot of people that are from Holocaust deniers to, moonlander deniers to, I don't know if you're going to talk about any of this.
Not those particular examples.
People can forget certain things in groups, and if you're not going to talk about that, we should talk about it later.
Great.
But the idea is that how you as an individual or as a person in a group change your mind or forget things or align your opinions depending on the dynamics of what's going on. And I think Dan not just has arguments about it, but he also runs computer simulations with academic agents to model these things, which would be very interesting to see. So Dan, thanks for coming. And
Great. Thanks so much to you guys. Thanks Marcelo and Amy for making this happen. It's been really great to be in Hanover for the past few weeks. All right, so as Marcelo said, I'm going to be talking about polarization. You guys already know, anyone who's been alive for the past couple years or longer knows that we're very polarized. So here's some voting patterns from the Senate, getting more disconnected. Here's some data about the actual population, how people feel about whether or not the government should do more to help the needy, the role of racism in affecting various people, and whether or not the government should help immigrants. Seems like we're getting polarized about these questions. So a natural thing to ask is, where does polarization come from? What causes polarization? So here's some things you might think cause polarization. So one thing you might think about what causes polarization is, look, we're just in different situations. Some of us live in the city, some of us live in the country. Those of us who live in the city might be focused on certain sorts of things, like trash pickup. Those who live in the country have, I don't know, you guys probably know, have different needs, so we might just be polarized because we have different needs. We might also be polarized because we have different evidence about questions. So let's say we care a lot about tax policy. Well, maybe I know a lot about some area of tax policy and you know a lot about some other area of tax policy. And because we have different evidence about the tax policy situation, we might disagree about what the most effective tax policy is.